An augmented matrix is a way to represent a system of equations as a matrix. And in an augmented matrix, it's important to keep each equation in its own row and each variable in its own column. So here's what it looks like. We set up the matrix, and the first row will be the first equation. And we take the coefficients of each variable, including the sign, and then we also take the answer number. So the first row of this matrix would be 2, -5, 6, 12. And then the second row, there's no coefficient for x. There's no x appearing in that equation. That means that we use a 0 for x in that row. The coefficient of y is 1, and the coefficient of z is -1, and the answer number is -4. And then the last row is 6 for 6x, -2 for -2y, and 3 for 3z, and the answer number is 61. So now in this matrix, the answers need to be separated from the variables. And the way we do that in the augmented matrix is just with a vertical line to show that this part of the matrix is representing coefficients of variables. This part of the matrix is representing the numerical answers in the equations. Example 2, write a system of equations from the augmented matrix. So in this matrix, we have 4 columns in the left section, so that means that we have 4 variables. First column is x, second column is y, third column is z, fourth column is w, and then the numbers are the answers for the equations. And this first row will be the first equation, so with those variables it would turn into 2x minus 5y plus 0z, so we're just not going to write z in this equation, plus 2w equals the answer 17. The next row has a 0 for x, so that means we're not going to write x in that equation. So 0x plus 10y plus 5z minus 7w equals 24. Next row, 1x. We could write 1x, but 1x is the same as writing x. So whenever we see 1 or whenever we see -1, we're just going to write the number with the correct, or the variable with the correct sign. So 1x would just be x. -1y, we're just going to write that as -y. 1z is just plus z, and then -1w would just be minus w, equals the answer number -105. And then the last equation, 10x plus 3y, and then -1z, we're just going to write minus z, and then plus 4w equals -26. So we can write these augmented matrices for 2 variable systems, 3 variable, 4 variable, 5 variable, however many variables you need for your system.